Hello, Sean Oskay, Professor of Design at Southern Oregon University, and today we're going to take some of the sting out of perspective. Drawing in perspective is really a lot easier than people may think about it. It's just a couple of rules. I really think there's 2.5 rules that I'm going to show you right now about how to make understanding perspective a lot easier. And sometimes it's really complicated by, there's things like this, mechanical perspective that I had to do in grad school, and I hated every minute of it. It's tedious, you do it at a drafting table, it takes forever. It does create a very accurate view of what a space will look like. But it also creates, in my opinion, this very kind of, I don't know, mechanical looking view. It doesn't have a lot of life in it. So I don't like that kind of perspective drawing. I'd much rather have you have slightly inaccurate drawings that are full of life and energy. So these are the kind of drawings that architects will do as thumbnail sketches, or we might draw a little sketch like this in a notebook. So I can clearly see in this drawing how to move around the space, that there's little glass doors here and a little coffee counter and all that. This is perfectly legible in terms of how I would move around in this environment, even if the perspective is off a little bit. I don't know that it is, but it could be off a little bit in this little sketch, and I would never know. You might draw a little sketch like this sitting in a coffee shop or something, and if you were to take a picture of this exact same view from where you were drawing the sketch and then overlay the two, you might notice that, well, yeah, I guess these windows are a little taller, and maybe these light fixtures don't come down quite as far as I drew them, and the beam spacing is a little off, or, well, who cares? We still get a sense of like, oh yeah, I recognize that place. I see the table and the chairs and the windows. I can understand what this space is. That's really what we're after when we're doing sketches and even a perspective rendering, even a formal rendering. Nobody's ever going to check to see. All you need to do is make sure that you're not so inaccurate with your perspective that it doesn't make sense to the person looking at it, or that you're kind of cheating. Like, oh, I can really get a 3-story set on my little tiny theater. It'll fit, you know. So if it doesn't really fit, then your drawing isn't helping you. But a little bit off here and there on the angles is no big deal. I'd much rather have you draw quickly and confidently than to be worrying about absolute accuracy. Just quickly reminding you that orthographic views, that's our drafting plate kind of views, don't have any perspective in it. When you're drawing a ground plan or an elevation or any other kind of drafting view, an orthographic view, they're not going to have perspective in those views, because that's not a good thing when you're trying to get an accurate measurement. Even the isometric views that we've been talking about that have more than one side, in this case 3 sides visible to you, those aren't actually in perspective either, even though they kind of look like it. Remember the magic Y trick that I taught you in Elements of Design, if you took that class from me? Well, there's the little magic Y right there, and you notice that what I was really teaching you was isometric projection, not actual perspective. When we deal with perspective, we're actually talking about lines that are going off to a vanishing point. So we've got lines that are sloping down above the horizon line and lines that are sloping up when they are below the horizon line, and they're going off to some kind of vanishing point off in the distance. That's really what perspective is, and that's what I want to show you a couple of these rules. So there's the first rule of perspective, which I think is the important one, and in order to help you remember that, I've got some visual aids.
I mean, I'm only crushing your heads. Crush you. What the hell do you guys find to talk about anyway?
So that's our Kids in the Hall sketch. That's reminding us that the first rule of perspective is that things that are closer are bigger than things that are further are smaller. And that's kind of obvious, right? But here's this strange person, you know, standing across the street squishing people's heads with his thumb. Well, if you were standing downtown somewhere and you saw your friend across the street, you might have a hard time noticing them, in that they're mixing in with other people and the trees and the fronts of the buildings and things. They're just sort of a small part of your field of vision. Well, then when you notice each other and your friend comes walking across the street, they're going to get bigger and bigger as they get closer, until when they're standing in front of you, they're going to be basically filling your field of vision. And you might hear me say that and think, well, obviously, of course, except it's really easy to forget that fact when you're sitting down to draw something. So let's have somebody else give us a hand here.
Okay, here goes. First, this is near. Right here, near. This is far.
Maybe Grover can help you remember the first rule of perspective. Things that are near are bigger than and things that are far are smaller. So really simple. One more way to get it stuck in your head. Here you go. Don't make me play Celine Dion again. Just get that idea about things that are farther away are going to appear smaller than things that are closer up. And we get that sense with all kinds of comedy vacation photographs or whatever, where we play around with that rule. And probably the most famous one ever is everybody who ever goes to Pisa has got to take this picture of the guy close to the camera holding up the Leaning Tower of Pisa that is far in the distance. He's closer to us, appears bigger than the tower that is farther away. And you see that same concept with a whole lot of optical illusion kind of tricks. You've seen these before, right? This guy is walking down the street, there's three men, they're all exactly the same size, except the guy in the back looks enormous, and the guy in the middle looks big, and the guy in the foreground looks normal, or he looks too small, or I don't know what. But the thing is, he's all the same size, but the building that he's standing next to is following the rules of perspective, but he's not. He's not getting smaller off in the distance like he's supposed to, so this guy looks huge. He looks taller than the building. We see that exact same effect happening here. This one's even harder to believe. The green lines, you know what I'm going to say, they're the same size. Well, our eyes look at that and say, there's no way those are the same size, because we're seeing this wall, basically, all these little white cubes stacked up. We see this green line and say, that's 1/3 of this wall's height, and this is 3/3, or the whole height of the wall, right? So when we look at this, we say, this one has to be bigger, because it's farther away and it's 3 times as big. Well, of course, when I add the horizontal lines on here, you can see that no, they're the same size. You might actually even see these purple lines kind of bowing, and that's just your brain going, does not compute, right? This has to be, there's something wrong. Those lines can't be horizontal, those can't be straight lines. That's your brain rejecting the fact that these lines are straight lines, because they're trying to understand, how can this line be 1/3 the size of that line? That doesn't make any sense. But these lines are not following the perspective rules, although the grid walls are, just like our little person. So we've seen that kind of example many times, where there's some kind of little optical illusion or some kind of little silly drawing that's just taking advantage of breaking that rule. So if we don't break that rule, then we can communicate things that actually do make sense to ourselves. Like this row of columns here. Notice too that things are getting smaller in the distance. So here's a line going off to a vanishing point right over here somewhere, and here's a line going off to that same vanishing point. And not only are the tops of these columns getting smaller, but they're also getting skinnier from our point of view too. So print this out on a piece of paper, cut this piece out, and then if we lift that up and set it over here, look how much it would cover, like 4 or 5 of these columns. This column width is a tiny sliver of this column width. Each one is getting skinnier, and they're getting shorter at the same time. So they're shrinking in all dimensions, all directions at the same time as they get farther away from us, just like your friend when they walk across the street from you. You can see this exact same thing happening in a photograph down this little colonnade. So if we say there's one line of vanishing points here to a central vanishing point off there in the distance, and we can follow down with the lines across the top of the columns and basically figure out that the horizon line, the view of the camera in this case, or the view of your eyes if you were standing there, is going to be right about there. So there's the central vanishing point that all these lines are going to. And that makes kind of good sense, because if you look over here at this little sheathing or whatever this is, this protective covering on the columns that's protecting these columns from tourist walking up against it or whatever. My guess is that's about 6 foot high, right? That would make sense. We're looking at these people off in the distance. That makes about sense. That's around 6 foot high. And part of the reasons why I think that is I can kind of compare that height to these people off in the distance, but also the person who took this picture probably was holding a camera up to their eye, or was using a tripod about a 5 foot or so height level. That would mean that the camera is a little bit shorter than this 6 foot, give or take, height, right? And that's interesting, because then we can see that slightly down below our horizon line, the line is pretty steep, but it's not as steep as it is way up here, where it's like 10 feet above our eye line or our camera position, and that line is going very steeply down. Well, if we were to do another line and trace the tops of these little column transitions, then we would see that that line is almost horizontal. It's sloping down a little bit, but not anywhere near as steeply as it is up here, because this is probably about 6 feet, maybe a foot above the camera's level. So that just gives you an idea of like how steep the angles change depending on how far away from the camera they are. So that's all 1 point perspective. You've seen this slide before, the idea of the horizon line and lines that are converging on that point. Let's take a look at some photos of some actual scenery. This little wall over here with the fireplace and the windows. We know that that wall is a square or a rectangle of some kind. Those are 90-degree corners over there. But if we were to go ahead and trace the top of that wall, we would say, and the bottom, we'd say that they're merging together at a vanishing point somewhere over here by this lamp, right? Which means our horizon line is going to end up right about here between those two lines. Well, we know that this is a 90-degree corner, and so is that, and that this edge is the same exact height as this edge. But because things that are closer to us appear bigger than things that are farther away from us, we see this trapezoidal shape in the wall here. So we get that kind of shape when we go to draw that wall, or when we look at it in a photograph and kind of trace it out like that. That's the kind of shape we're looking at, with the downstage edge, the wall closer to us, actually being bigger on the piece of paper or on the printout than the line that would be drawn on the upstage edge, because it's closer to us. So that's that rule of perspective. But let's look at the next wall over here. This wall is basically parallel to the apron, parallel to our camera view. So if we put the lines on top to trace that, we can see that, yeah, they're not really going off to a vanishing point. I mean, they probably are, but it's probably, miles away over here. These lines are sloping ever so slightly off into the distance. But basically, close enough, they're horizontal, because this edge of the wall is basically the same distance away from the camera as this edge of the wall. So we see this as an actual rectangle. It looks a lot more like it would in an elevation view. If we were to draw this out, it looks basically square on, because we're looking at it parallel. But let's look at the next wall over from that. That wall is a little bit farther upstage, right? There's this little landing right here. This wall, we can barely see that the coats are hanging on, and it's kind of its twin over here. My guess is that wall is about 2, 3, 4 feet maybe deep, because there's this landing right here, right? So there's got to be room for this door to open. So that wall's got to be, let's say it's 3 feet deep. So that means this wall is 3 foot farther upstage than this wall. So we see this little drop in the height here. And we can't see the bottom of it because of the steps, but my guess is about the same here. If we were to take these steps away, the bottom of this flat would be right about there, and the top of this flat is right about there. The reason it jogs down like that is this wall is farther away. So even though I bet these two walls are almost the same size when they're lying on the shop floor, this one looks smaller because it's farther away from us than this one that's next to us, even though the tops are parallel. Even there's none of this like perspective thing going on here. It's just going to be smaller off into the distance. So let's take a look at the second rule of perspective with some visual aids.
Romeo, Romeo, a young man of Verona. A comedy by William Shakespeare.
My lady!
Who's that?
Lord Shakespeare.
Anon, good nurse, anon.
So what's going on there in this scene from Shakespeare in Love? We're looking up at Viola's balcony right here. So we're seeing the underside of the roof. We're not seeing the floor of the balcony at all. When she looks down at Shakespeare down in the garden, we're seeing the tops of all the hedges, the top of his head. She's looking down from a high point of view. He's looking up at a low point of view. And that gives us the second rule of perspective. You see the tops of things below your eye level and the bottom of things above your eye level. So let's look at this photograph of this spiral staircase. My guess is the camera that took this picture was right about here, about the height of this tread. So we're looking down and seeing a lot of this first step and a little less of each one as we go up. See how skinnier it's getting, how smaller? We're seeing less of that until we're looking at just the side, just the edge of the step that's right there parallel with our eye level. And then this little bracket's in the way, but if it wasn't, we'd probably see a little sliver of the underside. Here we can actually see the underside there a little bit, some more, and then a lot more as it gets farther above our head. So things that we're looking up at, we're seeing the underside of the step. We don't see the wood part at all here. We're seeing the metal underside, but as soon as it gets below our eye line, we're seeing only the top of the step. And again, one of those things when you see it demonstrated like that looks so obvious, but when you're sitting down to draw it on your own, it can be tricky. So here's the kind of fake Juliet balcony in Verona, and it is sitting here above our eye level. This is like, I don't know, 15 feet up in the air. We're very clearly seeing the underside of this balcony. If this little parapet wasn't right here, we wouldn't be able to see the floor of the balcony at all. It's way up above our eye level. We can't see the top of that. Over here, there's only this little metal grate on this higher one. There's no way we're going to see the floor of this balcony over here. We're looking straight up at the underside of it because it's so much higher over our head. Here it is in a set example as well. So there's an upper level to this set, and we're seeing the underside of that upper level. We're not seeing anything of what's going on up here. This could be, painted pink, and we would have no idea. and we can come down the stairs all the way to we're only seeing the edges of the steps until maybe we see a tiny little sliver of this top one, and then boom, one more step down, and we can tell that the camera is probably right about that high. We're seeing a very foreshortened view of this good size floor space. I mean, this is a good, I don't know, 12 by 20 kind of chunk of floor space on this set. But because the camera is just a little bit above that floor level, we're seeing a very foreshortened sliver of a floor, and we're seeing the underside of this balcony over our heads and nothing of the top of that balcony because it's on the other side of the thing over our heads. So that's basically going back to this little slide that we've seen before, this little cube floating right in front of our eyes, right on the horizon line. If this cube had a stripe on it, it would be a straight line right down the middle. And that all of the top lines here are sloping down to the vanishing point, and the bottom lines are sloping up to the vanishing point. And we don't see the top or the bottom because it's right in front of our face. But if it were to float up a little bit, we would see the underside of that box, and then all of the lines are all pointing down to the two vanishing points. If it were to fall to the ground, we would see the top of the box, and then all the lines are pointing up toward the vanishing point. Does that make sense? We don't see the underside anymore because it's on the ground. We can't see the top of it because it's way over our head over here. And because it's right in front of our face, we can't see either one of those. Let's look at those in a little balcony view here. So this balcony level is right where the horizon line is. We're looking right at the side of this balcony, but we can see straight across it. We can see her feet because we're looking right at that level. We can't really see the underside. We can't really see the top. We go a little bit higher, we don't see her feet anymore because she's back on the balcony, but we're looking at the underside of the balcony. But here we can look down, see all of the floor and none of the underside. And that's because the horizon line is right there about the height of that middle balcony level. So if we were looking at it from the side view, here's what I'm talking about. Here's where we're looking. There's our horizon line, our eye level. We're looking straight at the side of this. We can kind of see along the side of the floor and see along the underside of it. So if there was a small object sitting here on the balcony, we might see that object the way we wouldn't here because it's being blocked by the balcony, but we could see that, but we're just not seeing the floor because we're looking kind of straight across that. However, we do see the floor down here because we're looking down at the floor, and whatever little small object was sitting there on the floor, we would also see that. We wouldn't see it up in here because we're looking at the underside of the balcony. We can't see any of the top of the balcony because this corner of the balcony is blocking our view. That's why we couldn't see her feet in that first picture. We could only kind of see her kind of calf up there. Let's go back to that little picture there. You can kind of see that's why, because the balcony is in the way of our seeing her feet. But here we can see her feet because the balcony is not in our way, and here we can see all of the top of the balcony. And that all has to do with where our eye is. Now that works in both directions as well. So I can take a look at this photograph of a staircase and see that, yeah, my guess is the horizon line, the height of the camera is right around in here, right about the second landing here. Because I can look down and see a little of the top of this landing, but I can't see any of this landing. So I'm guessing the camera's somewhere right around in here. So lots of this step, and then less as we get closer up, and then we're starting to see the underside of all of these steps as we go farther up the stairs. So that puts the horizon line kind of in that neighborhood, is my guess. But it also works in the other direction as well. My guess is the camera is kind of right about here from right to left, and also up and down, because we can see the facing, right, the riser of this step on this side of the line, little sliver of it right there, and then we don't see it anymore on this side of the line. Right here we're looking kind of straight down like the side of the floor of that balcony in that previous slide. We're looking right down the facing, but we don't actually see the facing, but we scooch over a little bit more, and there's a tiny little bit of facing, and then more and more and more as we move our way up the staircase. So we can look down at objects and look up at the underside of those objects, but it also works from side to side as well. So we're seeing this side of the facing on this side of the viewpoint, and we're seeing this side of the facing on the right-hand side of the viewpoint. Does that make sense? That was a little bit trickier, but basically it's the exact same idea, just rotated 90 degrees. We can look at this photograph of a set from up in the booth, and we're looking down at the tops of all of these flats here because our horizon line is way up in the air. But if we drop down into the audience view, we've moved our horizon line a lot lower, much more like the view that we would see from the audience instead of up in the booth. So this photo has the horizon line above the set. That's why we're looking down at the tops of everything here. We're seeing the tops of this little bar unit and the tops of the window seats. We're looking straight down at everything because we're way up in the air from the stage manager's point of view. Well, when we drop down into the audience's point of view, we're not seeing the tops of the flats anymore because they're above our horizon line. Our eye's down here somewhere. I can barely see the top of the bar now, and barely see the top of the window seats. And then anything above that, I'm not seeing the top of the mantle here anymore because it's now above my horizon line. So that's right about where we're sitting in the theater looking at this photograph of the set. We can see the exact same thing happening in this photograph. And one thing I want you to be aware of is where it is from the actor's point of view. So when you go to draw your little people into your figures, you don't want to draw the people kind of down here where they're not getting in the way of the scenery. All of these actors are standing in front of the scenery. The horizon line's a little high here. It's kind of back in the back of the theater. And all these actors are standing right through the middle of the horizon line in front of the scenery. So this guy right here is covering up this bench and part of the shrub, and this guy's covering up the little sculpture thing in the background. All these guys are in front of the scenery because they're at the same level as our horizon line. Let's take a look at this in a few more views. Here is a little SketchUp model showing two walls that are exactly the same size. One's on either side of our viewing plane here. And we're seeing this side, the inside view of the wall, but we can't see any of the other side of the wall here. Same thing is true on this side, except it's the reverse. We can see this side, but not any of the other side. These lines here, basically parallel to our viewing plane, pretty horizontal. Not perfectly, but basically they're horizontal. And then all of these edges are all going down to a central vanishing point. So this is basically kind of a one-point perspective too, because we're right in the middle of the view. So there's the horizon line, really easy to see in SketchUp because it changes the color from blue to green there on the horizon line. So there's the horizon line, and all of these lines are going down to that point, and all of those lines are going down to that point. And then when we drop below the horizon line, they're all pointing up to that point. But what happens if we scooch our view over a little bit? Now we've thrown ourselves into two-point perspective. This is actually dropping our view down from that same point of view. So here's the horizon line much lower, and we've got this line very steeply dropping down. And here, just slightly below the horizon line, there is this bottom edge of the flats. It's almost horizontal. The yellow line is so thick you can't really even see it anymore because that's how slightly angled it is up to this vanishing point over here. And if we look at the tops of those lines too, we can see now this edge that was basically parallel before when we were looking straight at it, now this is sloping down to some vanishing point that's way off screen off into the right hand side. But because this wall and this wall are basically in exactly the same plane, basically they're the same distance, look how it catches the top of that wall as it goes across. And the same thing is happening over here. If this wall were shoved upstage a little bit, 3 or 4 feet, then it would still be the same angle or very similar angle, but it wouldn't be hitting right on top of that. Basically, if we were to fill this in, take a big giant piece of plastic and staple it across the front of this here, we would add an extra plane to this that would now have this edge right here filling in that whole wall of the fourth wall of our set here. Let's raise our horizon line way up here. So now we've gone back up into the booth again here. We're looking down at the set mostly. Look at almost the inverse of the previous slide. Now this line down on the ground here that was barely perceptible is really steep, pointing way up to that horizon line. And the lines at the top that are really close to that horizon line are almost horizontal. This one's a little steeper than it was in the other point of view, but now we can't see the top of the walls just yet because the horizon line is still below the top of the walls, but the angles are very nearly horizontal. Now let's just go up a little farther. We're just floated up in the air a little farther. Look where our horizon line is. It's up above everything, just like the view from the booth of that set slide we were looking back. Now we do see the tops of these flats. So you're not going to see the tops of flats in your renderings unless you're actually above them. If it's a little wall or something, it's much lower than your horizon line, yeah, you'll see the tops, but you're not going to draw the tops of your flats unless you're drawing a view from a balcony or something, looking down at a very extreme angle to a set. So if we just trace all of these lines, you can again see all of these lines are all going to this vanishing point on the horizon line just offside of the view right here. So what happens a lot of times is students will do this little thing here. They'll come in and they'll be drawing they'll start their 4 walls with a little box set, and they'll do great on that back wall because that makes sense, and then it goes all wrong right there. What happens here is that students want to make these lines parallel here, these 2 lines. So these lines are okay that they're parallel because they are actually basically parallel because we're looking at this wall straight on. But these walls right here, this is not going to be sloped the way it is right here. So a lot of times the first kind of drawing I will get from students will look kind of like this. And then they'll have their people way down here off, they don't want to get in the way of the scenery. So the furniture and their people and their props and all those kinds of things are going to be down here on the floor. But that's not actually the way that we're looking at a piece of scenery unless we're looking at it from way up into the booth. So we can fix this by simply going in, just going to come in here and grab these little corners here and yank up on them and pull. I'm not changing that upstage edge at all, but I'm just yanking up on that one corner. And I'll go over here and I'll grab the other wall and I can yank up on that side. And that's making that downstage edge a lot bigger than the upstage edge. So instead of those two edges being the same, and I can grab all these people in the foreground and push them up where they belong in front of the scenery. Remember a guy standing in front of those shrubs a few slides back. They were in front of everything. So that's much more like what you're actually going to see from that same set. So this edge is bigger than this edge because it's closer to us. And all of the props and people and things, that's what people came to see. They didn't come to see walls. They came to see the actors, right? They're going to be in the way of the set. And that's just how it goes, right? Let's take a look at this. A couple more things here just to wrap up some of these notions of what 1 and 2 point perspective are all about, because that can be kind of confusing. So here we're looking down the street. All of these buildings are all parallel. We're looking right down the middle of the street. So we're basically looking at 1 point perspective. There's our horizon line, green and blue, really easy to find that. And now we're seeing all of these lines. Here's the curb lines. Here's the front of the buildings. There's the horizon line. And then all these windows and things are all pointing down to this one point of view here. So if I were to go ahead and rotate this view from one side to the other, you can see I'm going from 1 point perspective right there, and I'm rotating out of that to get into the other view. So now I'm looking at that in a 2 point perspective, and now I'm back into 1 point perspective. So all that means is like, well, where are you from side to side in the view? So if we look at that little shot from that little animation, now if we throw on all those vanishing points, we have the 2 vanishing points. So instead of everything going down to the distance way out here in the center of the street, we've got the same horizon line, but these buildings are now pointing down to this spot, and these are all pointing up to that spot, and then we have all these red lines that are going off on buildings that are on that side. So if we throw in some little colors on there, there's the blue planes, and there's the red planes. Anything that's in this plane, like all of these windows, all of these little cornice pieces here, all the sidewalk, all these things are in that blue plane, so they're all sharing the same vanishing point. Everything in the red plane, like this building and like the building across the street, are all sharing that same vanishing point off on the side. But if I take one of those buildings and rotate it a little bit, now that's got its own set of vanishing points. So it's got now these orange sort of gold yellow lines here, right? This is no longer in the same plane as its 2 neighbors. It's rotated a little bit, so it's now going off to a vanishing point that's off into a different position over here. It's not going here anymore, it's farther off onto the side. So pretty much every building that has a different plane is going to have its own set of vanishing points. So let's take a look at one last thing here with a set of grids on a little simple set here. This happens a lot when people want to put windows or pictures on the wall or any kind of props and things on their set. I just think about it as striped wallpaper, or in this case, gridded wallpaper, right? So we've got our vanishing point going off here somewhere, and we can see all of these lines are sloping down. Well, if we see the top of the doorways hitting one of those stripes in the wallpaper, or just slightly above it, this window or picture frame, whatever this is here, see how it's sitting right on that stripe, but then the top of it is going to be a little bit steeper, and then when it comes down to, when the stripes come down right to the horizon line, they're basically straight across, right? And then as soon as they get below the horizon line, they start dropping the other direction. Now they're pointing up toward that horizon line. So just think of the striped wallpapers on your wall, and that can really help you visualize that. This portion of the wall over in the front, however, is basically a grid square because we're looking right at it. So if we look at the vertical versions of that as well, we can see that, yeah, this spacing right here between these 2 grid lines, I just copied these 2 red lines, and I moved them over here, and you can see how much skinnier things are. The grid's getting skinnier in the vertical direction as well as in the horizontal direction, because these 2 red lines are the same 2 red lines that are 1 cube width over here, and here you can see they're like 1.5 cubes by the time they get over here, and this is just a few feet farther upstage, so you can see how that can get different really quickly. All of these lines, however, on the wall that we're looking straight at, though, are pretty close to horizontal. One thing that gets people a little confused, though, is when they start doing like planks on the floor, or maybe it's tiles like we're looking at right now. And people get the idea that, okay, well, over here, I know that these things are kind of radiating out at an angle. Where they get into trouble is when they get right onto the center one. It's like right where you're looking. It's It's like, how can that be straight up and down? That can't be straight up and down because there are lines in the floor. Like, and we can see as soon as we get on the other side of that center line, it starts to slope in the other direction. We'll just carry those lines off into the vanishing point, and you can see they're following the exact same rules that the walls are too. So yeah, you are having a vanishing point. In this case, it becomes a central vanishing point because all the lines are pointing at it there. And then to draw your floor planks or your tiles or whatever, you just snap all those lines to that same point. And you can see that, yep, that center stripe, that center plank or row of tiles or whatever it is, that's going to appear like a straight line going off in the distance because our eyes are right above that line in front of us. And then as soon as we move to one side or the other, they start to get sloped, and the farther away from our point of view they are, the steeper the angle of that slope. There's one more rule of perspective. This is kind of the half one. This is just something to bear in mind.
Then you bring your mind to rest against mine. The mind has no say in the affairs of the heart. The writing's on the wall. It seems like forever since we had a good day.
The third rule of perspective is simply that all perspective in 2D is an illusion. We're taking something that is 3D and putting it on paper. So if you're drawing a sketch or even taking a photograph, even this photograph, if you were to see it on your screen or print it out, it's flat, right? We're not actually in this train station, the subway station here. So we can get this effect played on us. This is paint on the wall, and this is paint on the floor, and this is a little trapezoid square. And if you stand in just the right spot, you can see this look like a little staircase floating in space with a red square next to it. But all of this is just paint on the wall and some paint on the floor. When you're walking up to this, it looks completely bizarre. You're like, what the hell is that? And if you stand in just the right spot, then the rules of perspective come together and we can see this optical illusion. Well, everything that we see on paper or on a screen is an optical illusion. You're watching a movie, the screen is 2D. So everything on that two-dimensional screen is an optical illusion. So we just have to kind of bear that in mind, that we need to kind of remember that our eyes evolved to see things in three-dimensional space, and we've been trying to depict it for thousands of years in a two-dimensional plane. So we can end up with a lot of things. These little tricks and these little rules that we can remember are just ways to help us create the optical illusion of a perspective drawing. Everything that you're doing when you're drawing a perspective is an optical illusion. That's why the wall that's farther down stage is actually being drawn bigger than the one that's upstage, even though it isn't really in reality. See what I'm talking about? So just kind of bear that in mind. You got to get some of those things, the rules of reality out of your head when you're drawing in 2D and actually look at what you're drawing at. That's why setting up that little stack of cereal boxes and whatever, or doing the little SketchUp model, all those things are so useful because you can actually look at something that is in reality and give your eyes something to watch. So one last thing to wrap it up.
Every book in the bookshelf of Bag End, every piece of parchment, every prop had to be built perfectly replicated at two different sizes.
You would build Gandalf's cart in two different scales, and it also had a forced perspective split rig on it so that you could get Gandalf and Frodo sitting side by side, apparently, although in fact Elijah Wood was sitting much further back from the camera than Gandalf, and you just pull the illusion off by the way you stage the scene.
Whatever you did, you've been officially labeled a disturber of the peace.